Welcome back. This is Mrs. Rubright with Geometry Honors. Today's lesson is 2.3, Apply Deductive Reasoning. Alright, so I want you guys to start by going to your textbook, and I want you to copy for your notebook on page 79. Page 79 in your textbook. The copy for your notebook, which is the laws of logic. So we have the law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. All right, so, and then we have the law of syllogism. And the law of syllogism, if hypothesis P, then conclusion Q. If hypothesis P, Q, then conclusion R. So if hypothesis P, then conclusion R. So basically we just cut out that middleman. So if we have like, if then, so like if A, then B. If B, then C. So we could go straight from if A, then C, because that B is overlapping on both. Where the law of detachment is more like they give you a if-then statement. They give you a random fact. If the random fact satisfies the if, our answer is whatever follows the then. If the random fact does not satisfy the if, then your answer is to negate whatever follows the then. And that is the law of detachment and the law of syllogism. So law of syllogism is our middleman. Law of detachment is if-then statement, random fact. All right, so I'm going to pause this video real quick while you guys finish copying down the for-your notebooks on page 79 of your textbook. So use the law of detachment to make a valid conclusion in the true statement. So A, if two segments have the same length, then they are congruent. That's your if-then statement, your random fact. You know that BC equals XY. So the two segments have the same length. That satisfies our if. So what's our answer? Whatever follows the then. My answer is they are congruent. For B, Mary goes to the movies every Friday and Saturday night. Today is Friday. So what's my if-then statement? Mary goes to the movies every Friday and Saturday night. So my if-then, I guess, would be like, if Mary or if it is Friday or Saturday night, then Mary goes to the movies. Yeah. So this one would be a flip one, even though it's just because of the way that it's written. It doesn't have like that word that tells you to flip it, but it's the only way to do it. So if it is Friday or Saturday night, then Mary goes to the movies. Today is Friday. Does that satisfy your if? Yes. So what's my answer? The then. Mary goes to the movies. If possible, use the law of syllogism to write a new conditional statement that follows the pair of true statements. All right, so the law of detachment was if-then, random fact. If the random fact satisfies the if, we go with what's the then. Law of syllogism was the middleman one, right? So like if A equals B, if A then B, if B then C, then your answer would be if A then C, right? You get rid of the middleman. So let's look here. If Ricky takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So you guys see the overlap? What's the overlapping statement? What's the middleman, the thing that's repeated? Jesse will be Rick's lab partner. So as long as the repeat is an if and a then, the repeat must be an if and a then. If the repeat is an if and a then, you just totally cut out the repeat, cut out the middleman, get rid of them. And my answer is, if Rick takes chemistry this year, then Rick will get an A in chemistry. Make sense? He's going to cheat off of Jesse. Jesse's going to do all the work as the lab partner. Jesse's going to work alone. Rick's going to reap the benefit of half the grade, right? He's going to get the grade that Jesse's earning. So not like a good scenario, but it's the problem. Don't cheat. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Do we have a repeat? This part's repeating, right? Is one of them an if and one of them a then? So get rid of them. Rewrite it. Rewrite the if then. If x is greater than 5, then x squared is greater than 20. Make sense? If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all sides are congruent. Which part repeats? If a polygon is regular, right? Is one of them an if and one of them a then? No. So this one you cannot do the law of syllogism. All right. If 90 degrees is less than the measure of angle R, which is less than the angle, less than the measure of 180 degrees, right? So if angle R is greater than 90, less than 180, then angle R is obtuse. The measure of angle R is 155 degrees. Does 155 degrees satisfy between 90 and 180? Yes. So what is our answer? Whatever follows the then. What's the then? Angle R is obtuse. So our statement is angle R is obtuse. Make sense? You have an if then, you have a random fact. If the random fact satisfies your if, your answer is what follows the then. If your random fact does not satisfy the if, what if it was 181 degrees? Then our answer would be angle R is not obtuse. Right? You just negate the then. Make sense? If Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. See, this is right up your guys' alley, right? Using the law of syllogism, what statement can you make? Is there a middleman? Is there an overlap? What's repeated? She can afford a car. Is one of them an if and one of them a then? One's an if, one's a then, so cancel them out. So our answer? Perfect. If Janelle gets a job, then she will drive to school. Can I get an amen? No, I'm kidding. Right? Is that not your dream? No, your dream is that mommy and daddy will just buy it, right? Yeah. But some of you will get a job and you'll pay for your gas or your car insurance and you'll feel really good about it. You guys only have a couple years until that could be a reality. State the law of logic that is illustrated. If you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. If you get an A or better on your math test, then you can watch your favorite actor. So which law of logic is this displaying? So this is the answer, right? This is what? Law of syllogism. You got rid of the middleman. Then you can go to the movies. If you go to the movies, that part cancels out, and you're left with your original if and then. So this is the law of syllogism. Good job. How about here? If x is greater than 12, then x plus 9 is greater than 20. The value of x is 14. Does that satisfy my if? Yes. So my answer is what follows the then? Law of detachment. What conclusion can you make about the product of an even integer and any other integer? An even integer and any other integer. Let's do some examples. An even integer, give me one. 6. The product of 6 and any other integer. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3, 18. 6 times 4. What are we realizing? You make a conjecture? What's going to happen? The product of an even integer and any other integer is going to be what? What's our conclusion? Even. It's going to be even and a multiple of that number, right? An even number times any integer equals an even integer. And then they went and did the same thing with letters, with variables. Decide whether inductive or deductive reasoning is used to reach conclusions. Explain your reasoning. So, we learned about inductive reasoning, right, yesterday? And what is inductive reasoning? You guys remember inductive reasoning? That was based on patterns, right? Wasn't it based on patterns? Yesterday, we were like figuring out the pattern. Where deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns to form a conjecture. So inductive uses patterns, right, and examples, where deductive reasoning is based on facts and laws of logic. Facts, definitions, and laws of logic. All right, so each time Monica kicks a ball up in the air, it returns to the ground. So the next time she kicks the ball up in the air, it will return to the ground. What do you guys think? Inductive or deductive? She kicks it up, it comes down. She kicks it up, it comes down. She kicks it up, it comes down. Raise your hand if you think inductive. Raise your hand if you think deductive. It is inductive, guys. She kicks it up, it comes down. 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 Continuing the pattern. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. What do you think? Inductive or deductive? All reptiles are cold-blooded. Parrots are not cold-blooded. So her pet parrot is not a reptile. Deductive, using facts and laws of logic. Are we okay on this? That is everything on today's lesson, which is 2.3, Apply Deductive Reasoning. We hope you enjoyed the lesson. Have a great day. Like and subscribe.